Dodge Ram trucks continue to maintain a well-deserved reputation for being hardworking, durable, and above all ruggedly powerful. When you add a legendary Cummins diesel engine to the picture, the result is an outstanding combination of performance and dependability that sets Ram pickup apart from other trucks in its class. This month's Master Tech program will introduce you to the latest generation of Cummins diesel power for the 1998 Ram truck, the new 24-valve 6-cylinder turbo diesel engine. We'll take an in-depth look at the many enhancements to the diesel power plant, including the most obvious changes, such as the new 24-valve cylinder head and valve train, and the Bosch VP44 fuel injection pump. We'll also cover new items from the lower end of the engine, as well as its lubrication system. Then we'll look at other new features of the fuel system and the air intake and exhaust systems. We'll also see what these changes will mean to those of you who service diesel engines in your dealership. This latest chapter in the evolution of Ram pickup will no doubt bolster its outstanding reputation, proving once again that the best never rest. Most of you are probably familiar with the previous model Cummins diesel available on Ram pickup. The new 24-valve engine provides increased horsepower and torque ratings over the old version. When mated with a manual transmission, the new engine develops 235 horsepower at 2,700 RPM and 460 foot-pounds of torque at 1,600 RPM. With an automatic transmission, the 24-valve diesel puts out 215 horsepower and 420 foot-pounds of torque at the same respective engine speeds. As an aid to identification, the engine serial number is stamped in the block on the vertical surface above the oil cooler. This number and other information can also be found on the data plate attached to the gear housing. Most of the bottom end of the 24-valve engine is the same as the previous version. There are some new features, however, that you may be interested in. The engine block does feature some structural changes, such as stiffening ribs on both sides to help reduce noise. Additional external ports and bosses have been added to improve plumbing connections and increase versatility. And straight-thread O-ring metric fittings have been incorporated into all sensor taps, as well as the lube taps in the oil galley, which provide better sealing than tapered pipe threads. A more efficient block heater that heats engine coolant is located behind the oil cooler on the right side of the engine. Previously a cup plug type, the new block heater now features tapered pipe threads. Mounted in the crankshaft between cylinder numbers 5 and 6 is a tone wheel for the crankshaft position sensor, which provides crankshaft speed and position data. The crank position sensor is located behind the starter, which you'll have to remove in order to service the sensor. Rounding out the enhancements to the base engine, water pump flow has been increased, which improves engine cooling. Among the new features in the lubrication system is a revised oil pump. The oil pump has redesigned rotors, and its capacity has been increased. Unlike the dump-to-sump arrangement on the previous diesel engine, excess engine oil is routed to the suction side of the oil pump, which improves flow and eliminates cavitation at higher RPM. The oil fill point is now on the cylinder head cover, a change from the previous engine's oil fill tube. The oil recommended for the 24-valve diesel is the same as that used in the past. Be sure to use only high-quality multi-viscosity oil that is specified in the service manual for diesel-powered Ram trucks. Before we continue our look at the features of this new diesel engine, try answering a review question. Where is the crankshaft position tone wheel located on the new Cummins diesel engine? A. Behind the oil cooler on the right side of the engine. B. On the crankshaft between cylinder numbers 5 and 6. Or C. On the engine block behind the starter. The correct answer is B. The crankshaft position tone wheel is mounted to the crankshaft between cylinders 5 and 6. Probably the biggest change to the Cummins Turbo Diesel for Ram truck is the all-new 24-valve cylinder head and the related changes to the valve train. The one-piece cylinder head cover is cast aluminum, and integrated color graphics improve the engine's overall appearance. The reusable one-piece gasket for the cylinder head cover makes service easier than the previous six-piece gasket set. And since the gasket is noise isolated, engine noise is reduced. The cylinder head bolts are now all one length rather than the three different lengths used on the previous product. This makes service easier and provides more uniform clamping on the head and gasket. Be aware that these bolts are not interchangeable with those from the 12-valve engine. The cylinder head gasket is of a new design that affords improved combustion sealing, and it too is not interchangeable with those used in the past. Another enhancement to the cylinder head is the shape of the exhaust ports, which increases combustion efficiency over earlier designs. The cylinder head has 4 valves per cylinder, 2 intake and 2 exhaust. The valves are smaller than those used on the 12-valve engine, and therefore are not interchangeable with previous valves. The intake and exhaust valves are also not interchangeable. You can identify the new exhaust valves by the small dimple in the center of the valve face. A new rocker arm design that allows for the removal of fuel injectors without disturbing valve lash is another improvement. The cross head enables the rocker arm to open 2 intake or exhaust valves at the same time. The crosshead socket acts as a pivot to allow the crosshead to open the valves. The valve train features wider camshaft lobes and tappet faces, as well as longer push rods, all of which help to reduce stress and wear. And since the fuel transfer pump is now electric, the camshaft has no mechanical transfer pump lobe. The camshaft is not interchangeable with any others. A camshaft position sensor, which senses when the number 1 cylinder is at top dead center, or TDC, is now mounted in the former TDC pin location. You'll also find a TDC indicator stamped on the outside of the gear housing cover. A new thermostat is found on the 24-valve cylinder head, and this component is not interchangeable with its predecessor. The thermostat is vertically mounted in the housing that is integrated with the cylinder head. That winds up the new items on the 24-valve cylinder head. Let's move on to the fuel system. The fuel injectors are located under the cylinder head cover between the rocker levers. They are secured with a hold-down clamp, cap screw, and shoulder bolt. The shoulder bolt should not be loosened when removing an injector. The fuel injectors operate at 4,500 psi pop-off pressure. Previously, the operating pressure was 3,600 psi. Fuel is routed through the high-pressure fuel line, inside the head, and through connector tubes to the injectors, where the fuel enters the injector from the side, different from the previous top entry. A new O-ring seal on the fuel injector body keeps engine oil out of the injector, and it keeps fuel out of the oil. A single 1.5 millimeter copper gasket or shim between the injector and the head is used with all 24-valve applications. This gasket should be replaced any time an injector is removed. It's important to remember that these fuel injectors are not in any way serviceable, and they are not interchangeable with any previous injectors. A major change to the fuel system is the switch from offset injection to centered injection, which provides many benefits. By locating the fuel injector in the center of the cylinder, the result is a more even fuel pattern on the top of the piston, which improves combustion. A centered injection system also helps equalize the temperature of the piston's ring pack, improving durability of the rings. Other benefits to the centered injection system are reduced oil consumption, reduced oxides of nitrogen emissions, and the elimination of a catalyst and an exhaust gas recirculation system on vehicles equipped with a California emissions package. Moving on, there is now a fuel return rifle bored through the cylinder head, which returns excess fuel from the injectors to the fuel tank. Next on the list of what's new in the fuel system is the Bosch VP44 fuel injection pump. As with the previous pump, A gear train in the front of the engine drives the injection pump at half the engine speed. The pump is mounted in a fixed position through an offset numbered key. The number on the key must match the 3-digit number on each pump. Previous injection pump mount keys, where used, were not specific. An arrow stamped into the top of the key should always face the pump. If it's installed backwards, a DTC may be set. When installing one of these injection pumps, be sure to have the keyway at the 12 o'clock position to prevent the key from falling into the gear train. There are no adjustments to make to the pump drive. And the injection pump itself is not serviceable. If faulty, replace it as an assembly. The injection pump employs a radial piston design to build high fuel pressure and delivers finely atomized fuel to aid combustion. 2 solenoids determine the timing and amount of fuel that is sent to the injectors. At this point, we need to look at the electronic controls for the fuel and air intake systems for the new Cummins engine. The electronic control system is all new and relies on 2 different electronic modules. Attached to the pump is a fuel injection pump control module, which is wired through a 9-pin connector. The pump control module receives signals from an engine control module, or ECM. It is through these signals that the injection pump control module operates the solenoids that meter and time fuel delivery. Designed by Cummins, the ECM is mounted to the driver's side of the engine behind the fuel filter. Both the fuel injection pump control module and the engine control module are compliant with the 2nd generation of onboard diagnostics, or OBD2. The ECM communicates with the fuel injection pump control module over a 2-wire data bus that is different from the CCD data bus. However, the ECM also communicates with the vehicle's PCM over the CCD data bus. The ECM uses information from its inputs for fuel system control, such as the non-adjustable electronic governor, which was previously mechanically controlled. Refer to this month's reference book for a complete list of inputs to the ECM. Among these inputs to the ECM is the accelerator pedal position sensor, or APPS, which is similar to a throttle position sensor. This 6-wire component provides throttle angle data and handles the idle on-off functions. By the way, don't adjust the idle stop screws on the 24-valve Cummins diesel. They are preset at the factory. The APPS is mounted to the back of another new item, the bell crank assembly. You shouldn't adjust the accelerator pedal position sensor, which is calibrated to its mounting bracket. If faulty, replace the entire bell crank assembly. The bell crank assembly serves as a junction point for the accelerator pedal linkage, the speed control servo cable linkage, and the transmission throttle valve cable linkage, which is the only one of the 3 that is adjustable. It's important to note that on the 24-valve engine, the ECM has taken over control of some of the fuel system functions that were previously controlled by the PCM. Another new item is the fuel system relay in the Power Distribution Center, or PDC. This relay supplies power to the fuel injection pump control module. A change to the fuel system is the addition of an electric fuel transfer pump, located on the left side of the engine near the fuel filter. Previously, the transfer pump was mechanical. Controlled by the ECM, the transfer pump uses pulse width modulation to provide 2 different duty cycles, one during engine cranking and one while the engine is running. At crank, the cycle time is reduced to prevent overpressure that may keep the fuel injection pump from operating. The electric transfer pump is self-priming on the low pressure side, while the previous mechanical lift pump was hand-primed. The transfer pump routes fuel through the combination fuel filter and water separator. The fuel filter contains a disposable cartridge-type element and also includes an integrated heater, a water drain, and an integrated water-in-fuel sensor. The fuel filter is similar to the previous version, except for the 2 ports that can be used for fuel pressure testing. Be sure to consult the service manual for the maintenance schedule for the fuel filter. An improved turbocharger leads off the changes to the air intake and exhaust systems on the new diesel engine. The turbo is redesigned for quieter operation and there are no adjustments you need to make. And while we're on the subject, don't remove the air cleaner cover to check the air filter. Use the filter minder. There are two intake manifold air heater elements located under the intake plenum. Previously controlled by the Jeep Truck Engine Controller or JTEC Powertrain Control Module, the intake air heaters are now controlled by the Fuel System ECM. The heaters warm intake air, which improves cold starts and helps to reduce white smoke. The heaters operate for a longer cycle time during cold ambient temperatures. Because of this, the ECM also controls the wait to start lamp on the vehicle's instrument panel. Another new item is a manifold air pressure or MAP sensor. This component is an input to the ECM and may also be referred to as a boost sensor. A one-piece exhaust manifold, which includes cap screws and spacers, is also new. Its ports are round instead of square, which increases exhaust flow. The important thing to remember here is to use the updated screws and spacers when replacing the exhaust manifold. Other benefits of the new manifold include reduced exhaust leaks and warpage. It is not interchangeable with other units. Now that you've seen what's new on the Cummins Diesel, try another review question before we go over some diagnosis and service tips. True or false? The accelerator pedal position sensor, or APPS, is fully adjustable. That's false. The accelerator pedal position sensor is not adjustable at all. If it is found to be faulty, replace the bell crank assembly. It should come as no surprise that when an engine is redesigned, especially one that replaces a mechanical control system with electronic modules, diagnosis and service of customer complaints with that engine will also see some changes. One advantage of electronic control of engine systems is enhanced diagnostic ability through tools such as the DRB3 scan tool. Diagnostic trouble codes, or DTCs, can be read with the DRB3 on diesel-powered vehicles in much the same way they are on other vehicles. Make sure that you choose the module you want to read trouble codes from, such as the PCM or ECM. DTCs that are accompanied by an illuminated malfunction indicator lamp, or MIL, are usually emissions related, while a check gauges lamp will be associated with DTCs that indicate problems in other areas. You can also use the DRB3 to monitor sensor readings with the sensor display and check the operation of electronically controlled switches and solenoids with the actuator tests. The DRB3 can also be used for system tests while the engine is running. Use the DRB3 pressure tester to check for restrictions on the inlet side of the transfer pump. Typical readings on the inlet side of the transfer pump should be no more than 6 inches of mercury. Another tool that is used for diagnosis of the diesel fuel system is a combination pressure vacuum gauge, special tool number 6828. To check the pressure side of the transfer pump, you'll need to obtain a fitting to adapt the gauge to the inlet side of the fuel filter. See this month's reference book for complete specifications on adapters for the combination pressure vacuum gauge. On the inlet side of the filter, up to 16 psi is normal with the key on and engine off. During engine cranking, the pressure reading should be about 7 psi, while a minimum of 10 psi with the engine running is typical in a system that is operating normally. Many times the diagnostic trouble code description alone will be the only thing you need to solve the problem. On low power complaints, for example, MAP sensor malfunction DTCs and fuel-related codes, such as a transfer pump circuit failure, may be present. Other possible causes of low power complaints include the fuel temperature too high, coolant temperature too high or low, or incorrect turbocharger wastegate settings, all of which may set a DTC. Conditions such as air in the low-pressure fuel system, low pressure in the transfer pump, or low oil pressure probably won't set a code and require further diagnosis. A clogged fuel filter can be a cause of poor performance. A pressure drop across the filter test ports of 5 psi or greater indicates a clogged filter. Other symptoms of a clogged fuel filter can be white smoke or misfiring at high speeds and light loads, and loss of power at medium to high speeds. The repair for a clogged fuel filter is, you guessed it, changing the filter element cartridge. Be sure to check for any intake air restrictions that could be adding to a low power condition. Also check for loose clamps on the air ducting from the turbocharger to the intercooler, and from the intercooler to the intake manifold. The March 1996 MasterTech program covered low power complaint diagnosis on the 12-valve Cummins diesel. Hard start complaints may be caused by a problem with a transfer pump. Insufficient battery voltage at the fuel injection pump can also cause hard starts. Check for voltage that is less than 7 volts. The new Cummins engine also brings with it some service procedures that are different than they have been in the past. One of these procedures is purging air from the low pressure side of the fuel system after a fuel filter change or if the vehicle runs out of fuel. First, loosen the banjo bolt at the low pressure fuel supply line on the side of the fuel injection pump. Next, momentarily engage the starter, but do not allow the engine to start. Then release the key to the run position, but do not turn it back to off. The transfer pump will continue to run and purge air from the fuel system for about 25 seconds. Repeat the process until all air has been eliminated from the system. Then tighten the banjo bolt at the supply line to the fuel injection pump. Once you're satisfied that all the air has been purged from the system, attempt to start the engine. Once it starts, be sure to check for any fuel leaks while the engine is running. To purge air from the high pressure side of the fuel system, first loosen any two of the fuel line connections at the cylinder head to cylinders 1, 3, and 4. Then crank the engine until fuel without any air bubbles squirts from the loosened fuel lines. Tighten the fuel line fittings to 40 Newton meters, or 28 to 30 foot-pounds. Proper torque here is critical. Then start the engine and raise the engine speed to between 1200 and 1500 RPM. The engine may run a little rough and be quite noisy until the remaining air has been purged from the other high-pressure lines. Now give our last review question a try. During an engine running fuel pressure test on the pressure side of the transfer pump, what should a normal reading be? A. At least 10 psi. B. About 8 psi. Or C. Not more than 7 psi. A is the correct answer. An engine running pressure test of the pressure side of the transfer pump should show a minimum of 10 psi on a system that is operating normally. With all the enhancements to the 24-valve Cummins diesel engine, you might want to register for a training course to come up to speed on this next generation of diesel power for Ram trucks. There are 2 new courses available at your local training center. A course that covers the base engine is number 0140308. And the diesel fuel system course is number 0841016. That's all the time we have for this month's program. MasterTech will continue to keep you up to date on the 24-valve Cummins diesel engine as new information comes available.